Hello dear GATE aspirants, welcome to VEDAGATE Academy. In the previous discussion, we are done with the impulse input or impulse signal. Impulse signal is also called as Dirac delta function or sudden shock or sudden input. We saw its Laplace transform and inverse Laplace transform. It's somewhat about its application. I told you all the applications I'm not going to list out here. Few we will discuss, a few when the time comes we will apply directly. At that point of time we will understand how to apply. So the next discussion we have to start with is a step function. We are done with impulse. We have to start with a step. Let's understand about the step signal. Yes, step function or step signal. Step function. Step function or step signal. Step function or step signal. In the previous discussion, we saw that Laplace transform of 1 does not exist. And I told you that most of the people will give the answer as 1 by s, but it is not. We have two types of Laplace transforms. One is unilateral Laplace transform, another one is bilateral Laplace transform. By default, if nothing has been mentioned about the question, Laplace transform means bilateral, means you have to take the integration limits from minus infinity to plus infinity. If the examiner will mention as if the examiner mention it as a unilateral Laplace transform, then the Laplace transform of 1 will be 1 by s. Unilateral Laplace transform of 1 is 1 by s. Please do remember that point. Yeah, unit step function or step signal. Let's see the definition of it. Let's see the mathematical definition of it. So step is denoted with a into u of t, a into u of t. Yes, come on. I'm not writing unit step function. I'm writing it as step function. Unit means a equal to 1. Yeah, you have to remember one point, that is unity means always 1. Unity means always 1. So this a into u of t is equal to a for t greater than 0. Understand? The symbol to denote step function is a into u of t, where a is the height of the step, please. Height of the step. This a will denote as height of the step. I'm writing here a is height of the step. Height of the step a is. Okay. Then let's understand, if a into u of t is equal to a means how much might be the u of t value? 1. Definitely. Yes, a into u of t is a, means how much is u of t? 1. And just we saw about for t greater than 0 is equal to 0 for t less than 0. For t less than 0. Means I can say the step signal will exist after t is equal to 0. After t is equal to 0. Or it will start at t is equal to 0. Before t is equal to 0, it is 0. Let us show this one graphically. There is a small ambiguity in understanding this one. At t is equal to 0, what is that we are going to see? What is that we are going to see? Come on here. Let's sketch its graph, please. Let's sketch its graph. I'm sketching its graph. Observe clearly. This is t. This is t. Yes. This is 0. In the previous discussion, I clearly explained you about 0 plus and 0 minus and 0. What is the physical significance of 0 minus, 0 plus and 0? Magnitude wise, all three are equal, but operation wise, all three are not same. We discussed. Come on. Let me draw. According to definition, a into u of t is a for t greater than 0 equal to a equal to 0 for t less than 0. But graphically, we will be showing like this. Graphically, we'll be showing like this. This magnitude is a. Then you might got a doubt, sir. You told that a into u of t is a for t greater than 0, but at t is equal to 0 itself, you are showing it as a. Yeah, that is a step discontinuity, please. That is called as step discontinuity. The value of a into u of t at t is equal to 0 is a by 2. Yeah, I'm writing practical value, please. Practical value. So a into u of t is equal to a by 2 at t is equal to 0. Sir, how we got this a by 2? From Gibbs phenomena. Yes, from Gibbs phenomena. Gibbs is a scientist. Gibbs phenomena. You'll be understanding what is this Gibbs phenomena in signals and systems. From Gibbs phenomena, at t is equal to 0, it is taken as the average value. What is before t is equal to 0 value? 0. Before t is equal to 0 value is 0. Yes, at t is equal to 0, a into u of t is equal to previous value is 0, the next value is a, and its average. How much it is? A by 2. We have to take the average of the previous value and the next value. And why? Because at t is equal to 0, it is looking like a step discontinuity. Yes, the function is discontinuous here. A sudden rise here. You are looking at a sudden rise here. Yes, means let me draw it once again. Let me draw it once again. Yes, come on. This is t, this is 0. Yes, this is 0. Come on, here it is a. But at t is equal to 0, it is shown as a by 2. But we are not going to represent that a by 2 in the graph or in the what you call waveform. Here we are not going to represent that a by 2. See, ideally, step function is represented like this. Step function is represented like this, and this is a into u of t axis. This is a t axis. Now, if you observe carefully, what is the difference between a DC signal and step signal? So this is a big confusing question for many of the students. Let's see what is the difference between DC signal and step signal. Now, if I ask you to draw example, that is f of t is equal to 2. If I ask you to draw f of t is equal to 2, f of t is equal to 2, and I did not mention anything about where it exists, where it does not exist. By default, we have to take that everywhere it is going to exist. If we draw the graph of it, we are going to get like this. This is t is equal to 0. This is t. Yes, this is f of t. Yes, f of t. This is the function 2. F of t is equal to 2. F of t is equal to 2. Now, this is called as DC signal. DC signal is the one which is existing from minus infinity to plus infinity. Minus infinity to plus infinity. Now, what is the difference between DC signal and step signal? DC signal and step signal. Yes, sir. Now, if I ask you to draw f of t is equal to the next graph we are going to draw here is f of t is equal to 2 into u of t. 2 into u of t. People know that u of t value is 1. Sir, 2 into 1 is 2. Both are same. No, not same, please. There is a lot of difference between that DC and the step signal. Let me draw. I'm drawing it here. Observe. I'm drawing it here. Observe. This is t. This is 0. Yes, this is t. This is 0. Now, this will be the step signal. This will be the step signal. Yes, step is a signal which exists only for t greater than 0. Only for t greater than 0. DC signal is a signal which exists from minus infinity to plus infinity. Always it exists. Yes. Now, one practical understanding of this step signal. One practical understanding of this step signal. Now, I'm just showing a circuit here. Is observe here. This is 10 volts. This is 10 volts. Now, yes, there is some inductor I'm taking here. There is some inductor I'm taking here, L, and this is this switch is closed at t is equal to 0. Now, what is the voltage across this inductor? What is the voltage across this inductor? So VL of t, many of you write it as VL of t is equal to 10, but I will call it as 10 into u of t. Why is that 10 into u of t? Why? Because this 10 volts, yeah, you may ask a question, sir, this 10 volts is a DC. Yes, I too accept with that, it's a DC, constant value, but that DC input is applied across inductor for t greater than 0. Before t greater than 0 means for t less than 0, this input is not getting applied across this inductor. Therefore, to represent when this 10 is coming into picture across that inductor, I am taking this function u of t. Why? Because u of t is the signal whose magnitude equal to 1. 10 into 1, there is no change of value. 10 into 1, there is no change of value. But what is the significance of this u of t? U of t signifies that the 10 input, the 10 DC input is getting applied across the inductor for t greater than 0. This is the practical application of this u of t. See, or the same circuit I can draw in another way. The same circuit I can draw in another way. Please observe, please. I will be taking like this. 10 into u of t without switch I will be taking. No issues, please. 10 into u of t without switch I will be taking. Here, tell me, what is the voltage across inductor? VL of t. Yes, this is VL of t. Tell me, what is VL of t for t less than 0? Equal to 0. Why? Because what's the input? 10 into u of t. U of t is equal to 0 for t less than 0. Therefore, voltage across inductor is 0 for t less than 0. Is equal to 10 for t greater than 0. VL of t is equal to 10 for t greater than 0. Means a DC input with switch which is closed at t is equal to 0, or the DC input with the multiplication of u of t, both will represent the same. Both will represent the same. Now, if I draw one more circuit, this is a circuit. Observe, this is 10 volts. Yes, no switch and no u of t. Now here it is very much different. So VL of t is equal to 10 for all t. Yes, I can write here for all, means for minus infinity less than t less than infinity. For all time, the voltage across inductor is 10. This circuit is very much different from the previous two circuits what we have taken. So this is the significance of a step function. Now, if I want to know, or if I want to get, see, I have a signal like this. This is 0, and let me draw it completely. Now I have a signal from -2 to +2 with magnitude of 4. I want only this part. I want only right side part. I don't want this left side part. This is f of t. But in f of t, I want only right side part. What is the equation for that? You multiply this one with u of t. What is the magnitude of u of t? U of t magnitude is how much? 1. U of t magnitude is 1. This is 0. This is t. Now what happens for t less than 0? What is the magnitude of u of t? 0. So 0 into anything is what? 0. So this part will get vanished. What we are going to get? We are going to get like this. Only right side part we got. So if you want to make any signal or to exist after t is equal to 0, multiply that signal with unit step function. What does it mean by unit step function? If a equal to 1, that function is called as unit step function. So that much simple it is. Yes, let us define unit step function first. If a is equal to 1, I am writing here. If a is equal to 1, then what? U of t, a into u of t, 1 into u of t must be equal to what? A. But a is how much value? 1 for t greater than 0 is equal to 0 for t less than 0. So this is the definition of unit step function. That a represents the height of the step. So this is the discussion of step function in time domain. Now what's our requirement? We have to convert this time domain signal into frequency domain. I told you that frequency domain is having a lot of advantages. After completion of all these basics, we will see the advantages of frequency domain. Now let's find the Laplace transform of u of t, or a into u of t. Yes, sir. Laplace transform of step function we want, or step signal we want. A into u of t we want. What is the formula? Yes, integral minus infinity to infinity. What's f of t? F of t is a into, yes, u of t into, what is the kernel? E power minus st dt. Yes, now observe here. Now u of t is the signal which is existing only from 0 to infinity. Or split this integration like this, minus infinity to 0. What is the value of u of t from minus infinity to 0? 0 into, what is the kernel? A is also there. Okay, let's take, no issues. E power minus st dt plus integral of 0 to infinity a into, what is the value of u of t for t greater than 0? 1. U of t for t greater than 0, how much it is? 1 into e power minus st dt. Yeah. Now from this, this integration will become 0 plus integral a will come outside of the integration, yes, as it is a constant. Then what you are going to get? E power minus st by minus s from 0 to infinity. If you calculate this integration after substituting the limits, you are going to get a by s. What's our understanding? Laplace transform of a u of t, please. Laplace transform of a into u of t. How much, boss? A by s. Laplace transform of a into u of t is a by s. Then what is the Laplace transform of unit step function, please? Answer, brother. You can easily answer. Laplace transform of u of t, in the place of a, just you substitute 1 by s. I want to answer from you. You must be in a position to answer within no time. Yes, this is about the Laplace transform of step function. With a by s, unit step function a equal to 1 by s. Now let me discuss one simple property, then after that we will see some problems. what is the Laplace transform of f1 of t plus f2 of t? Yes, is equal to Laplace transform of f1 of t separately plus Laplace transform of f2 of t separately. That is equal to how much more? f1 of s plus f2 of s. Means when in addition form we can apply Laplace transform separately. Now my question is, in the previous discussion we are done with impulse. Now I am giving combinedly the Laplace transform of impulse and step. Tell me the answer. Laplace transform of example, what is the Laplace transform of 2 del of t plus 3 into u of t? I can apply separately Laplace transform of 2 into del of t plus Laplace transform of what ma 3 into u of t. Now that is equal to 2 into del of t Laplace transform. 2 will come outside of the Laplace. Out also, why? Because it is constant outside of the integration. What is the Laplace transform of del of t? 1. We proved in the previous discussion. 2 into 1 plus 3 will come outside. What is the Laplace transform of u of t? 1 by s. Just now we discussed. Now the answer is 2 plus 3 by s. The answer is 2 plus 3 by s. This is the way how to find the Laplace transform of a signal which is given in combined form. Now let me take one more example. I am expecting answer from you for this question without pen paper. You need not to solve. Directly we can give the answer within one step. What is inverse Laplace of 3 by s plus 6? What is inverse Laplace transform of 3 by s plus 6? It is same for inverse Laplace also. Let me discuss this property. This property note. If you want, you can take it as note. That is inverse Laplace transform of f1 of s plus f2 of s is equal to inverse Laplace transform of f1 of s plus inverse Laplace transform of f2 of s. Separately you can do. Here you can use that property over here. What is that? Inverse Laplace transform of 3 by s plus inverse Laplace transform of 6. How much is 3 by s inverse Laplace transform? 3 into inverse Laplace of 1 by s. Laplace of u of t is 1 by s, means inverse Laplace of 1 by s is u of t, yes, plus 6 into del of t. Just list out the note point, please. Note that is note you have to write and remember. Yes, we found it. Just I'm not asking you to remember directly. We proved it. That's why you can you have the proof. If you forget, also you can get by using the calculations. The first one is Laplace transform of a del of t is equal to a, and inverse Laplace transform of a is equal to a del of t. Yes. Second one is Laplace transform of a into u of t is equal to a by s, and inverse Laplace transform of a by s is equal to a into u of t. Vice versa, please. Yes, vice versa. So these things what we discussed till now. So with this we are done with step function. I given you the practical use of this step function also. If you want to make any signal to exist after t greater than 0, then multiply that existing signal with u of t unit step function. Why with u of t, sir? U of t magnitude is 1. If you are multiplying with any function, then that magnitude will not change, but the existence will change. Here, if you take, it is existing from -2 to 2, but if you multiply with u of t, it will exist from 0 to 2 only, or 0 to infinity only, without change of any magnitude. That is the use of unit step function. There are many uses. Later we will be finding all the uses when time comes. Okay, then what is the next signal? Before I enter into the next signal, we discussed first impulse, then step. After that we are going to discuss about ramp. You might be thinking, sir, is there any link between these signals to discuss in a sequence? Yes. Why I am going in this sequence only? Means first impulse, next step, ramp, and parabolic. Why I am going in this sequence only? There is a link between these signals. That's why I discussed. What is that link? Let's see. What is that link? Let's see. This is a very important note point, please. An important note point, that is, observe here now very carefully. Observe here very carefully. Yeah. Integration of minus infinity to t del of t dt. Yes, integration of minus infinity to t del of t dt will give, yes, u of t. Yes, yes, you can get it. You can get it very easily. Why? How, sir? How I can get? We know the impulse definition. 0 minus 2 0 plus del of t dt is equal to 1. Del of t dt is equal to 1. Now from this one, how to get this? I'm going to prove. Yes, sir. Let's take the proof. But what's my expectation is you all remember this one. In the previous discussion we got this one. You must remember this one, please. Come on. We will be proving how we got this one. Now, what are the integration limits I'm taking from minus infinity to t, minus infinity to t. Now, let me draw that impulse signal. Yes, this is the impulse signal. Now, I'm taking the integration. From here to here. Observe. I'm taking the integration like this. Observe, please. Very carefully, you have to observe. I'm taking the integration from minus infinity to some t which is less than 0. I'm taking the integration from minus infinity to t. The t is less than 0. Come on here. Integral of minus infinity to t del of t dt is equal to 0 because I'm at a for what t less than 0. I'm taking the integration for t less than 0. Yes. Here, why? Because del of t is here. You did not encounter del of t. Therefore, how much I got? Integration of minus infinity to t del of t dt is equal to 0. Why? Because I am taking the t value for t less than 0. Now let me take for t greater than 0. Integral of minus infinity to t del of t dt is equal to, let's mark it first. I am taking the integration, yes, for t greater than 0 somewhere here. I'll call this one as t1, this one as t2. Yes, is equal to, I can write this one. I can write like this. Integral of 0 to, why? Because the impulse signal will exist only at t is equal to 0. That signal is included or excluded in this integration? Included. Signal is included. Why? Because I am after 0. In the before integration, the signal is not included. Why? Because we are before 0. Now here, integral 0 minus 2, 0 plus del of t dt is equal to 1. You know it very well. This is a property or an identity given by the scientist. This is not our proof, please. Scientists given this one, but we taken the practical impulse and we saw its area equal to 1. Integration of any signal will give you area under the curve. Now come on here, all of you, is equal to 1. Now for what? T greater than 0. Yes, what we got is for t greater than 0 we got. For t greater than 0 we got this one. Yes or not? Now come on. Signal is equal to 0 for t less than 0. From here is equal to 0 for t less than 0. Is equal to 1 for t greater than 0. Which signal is having this definition? Unit step signal. Yes. U of t is equal to 0 for t less than 0. U of t is equal to 1 for t greater than 0. Yes, we got u of t or not? Yes. The result for this integration is 0 as it is t less than 0. The result for this one is 1 for t greater than 0, which is signal value is 0 for t less than 0 and equal to 1 for t greater than 0 unit step function. Yes, this is the proof for integration of the impulse signal will give step signal to us. Now what is vice versa? Derivative of the step signal will be giving as impulse signal. Yes, integration of impulse signal will give us a step signal. Yes, if you take here 2 del of t, you are going to get a 2 into u of t. That's it. The magnitude is very simple, just as it is a multiplication factor, height of the step or area of the impulse. Here if I take 2 into del of t, I'm going to get here 2 into u of t. That much simple it is. Yes, please, these two are very, very important. Later in time response analysis, number of times I'm going to use these identities. Yes, please do remember. So with this we are done with what signal? Step signal and impulse. The next signal is a ramp signal. Let's go for the ramp signal. Yes, come on, take the heading. Ramp signal. Yes, ramp signal. We will be denoting it as R of t. We are denoting it as R of t. Yes. Let's define it first. How to get ramp signal from step signal also we'll see. Integration of step will give us ramp. That also we'll prove just by taking small integration. Okay. First let's define ramp. Then we'll prove from step signal how we are going to get ramp signal. R of t is equal equal to r of t is equal to some a into t for t greater than 0. A into t for t greater than 0 is equal to 0 for t less than 0. Here also you need to understand one thing. This signal is also a right side signal, means which is existing only from t greater than 0. T greater than 0. Yes, t is equal to 0 onwards. Only right side. Left side its value is 0. Now observe here, I told you that unit step function is used to represent right side existence of a signal only for t greater than 0. Now can I write this total? Can I write this total as simply a into t into u of t? A into t into u of t. R of t is equal to a into t into u of t. Very simple representation. Yes. A into t. U of t is equal to 1 for t greater than 0. Yes. A t. U of t is equal to 0 for t less than 0. Done. Yes. Instead of writing in this manner, we can write in this manner very easily. Now, let's understand what is that a. What is that a? Yes. Now, if you take simply y is equal to mx, example I am taking here, y is equal to mx if you take, what is this m? This m is slope. You know it very well. Here instead of y, what we have r of t. Instead of x, what we have t. Instead of m, what we have a. Yes. This is for t greater than 0, equal to 0 for t less than 0. Now, can I write that a as a slope? Yes. This a is what? My slope. Slope of the ramp. A is called as what? Slope of the ramp. How to find the slope of the ramp also we'll see. Here directly, just by looking at the signal we can say. Now, for example, if I'm writing like this, r of t is equal to 2t into u of t. What is the slope? Ramp slope is, how much it is ma? 2. Ramp slope is what? 2. Here, a into t is a straight line. Yes, at. Y is equal to mx. Just directly you can compare this one with y is equal to mx. Instead of x, what we have? T. Instead of x, what we have? T. But only difference is y is equal to mx is a straight line passing through origin. It's a straight line passing through origin. Observe in this way. But r of t is equal to a into t is a straight line starting from origin. For t less than 0, its value is 0. Please. For t less than 0, its value is 0. Come on here. Let me draw it. Then, or first, let me define about unit ramp signal. Not unit step signal, please. Unit ramp signal. If a is equal to 1, or let me take the heading unit ramp signal. Unit ramp signal. If a is equal to 1, if a is equal to 1, then r of t is called as, yes, then r of t is called as what ma? Is called as unit ramp signal. Unit ramp signal. What is the representation? R of t is equal to what ma? T into u of t. That's it. I am not writing for t greater than 0, less than 0. That u of t will take care of it. U of t will say that it is equal to t for greater than 0, equal to 0 for t less than 0. Yes. Now let us sketch the graph. Let us sketch the graph. Yeah, you know it very well from mathematics. It's a straight line. It's a straight line starting from origin. Let me draw first ramp. Then we go for unit step ramp sketch. Unit ramp sketch, not unit step. Yes, this is yes, ramp signal. This is ramp signal. Now there are various methods to find slope. There are various methods to find slope. I will give you all the methods to find slope. I will give you all the methods to find slope. Yes, sir. Let me take it once again, the diagram once again here, and I will give the methods to find the slope. I'm taking diagram once again here. Observe. Observe carefully, please. This is a t-axis. Yes. Come on. This is the ramp signal. This is the ramp signal. Yes. R of t. R of t. What is R of t? R of t is equal to a into t for t greater than 0, equal to 0 for t less than 0. I want slope. Directly by looking, as it is a straight line, by looking at the constant we can say or derivative it. dr of t by dt. dr of t by dt is what ma? A is equal to slope. Derivative of a function will give the slope of that function at that instant of time if you substitute that time. Here slope is constant because it is a straight line. It is a straight line. Suppose if you take a curve, if you want to find the slope of this curve, if you want to find the slope of this curve, This curve is having a single slope? No, it is having number of slopes, infinite number of slopes. At each point it is going to have different slopes. Then how to find the slope of this one, sir? Take the function. Suppose this function is some t square. Suppose this function is some t square. What to do, sir? Derivative it. dt square by dt square. t square by dt square. At what point you want? You want slope at t is equal to 2. Now put t is equal to 2. Then you are going to get the slope of this one. Means finding slope is very easy. Finding slope is very easy. How to find slope of any given function? Whatever may be the function, whatever may be the function or signal, find its derivative. At what point you want the slope? Substitute that point in that result after making the derivative. Here, as it is a straight line, we got only one slope. Yes, sir. All straight lines are going to have single slope. Means if you take a straight line, its slope is constant at any point of time. Okay. So dr of t by dt is equal to a. Or what is the slope formula? Slope is equal to childhood formula, y2 minus y1 by x2 minus x1. What is our y-axis here? R of t. What is our x-axis here? T. So r of t2 minus r of t1 by t2 minus t1 is the formula. This is one of the formula. This formula is exclusively applicable only for straight lines. See, some of the students not having good basics from mathematics. That's why I'm discussing every point, please. So this is applicable for any given, either it is straight line or curve, whatever it is, you can apply that formula. But this formula is applicable only for straight lines, please. This formula is applicable only for straight lines. Now, what is r of t2? A t2. What is r of t1? A t1 by t2 minus t1. If you simplify this, you are going to get it as a. Then how much is the slope? Slope is equal to a. There is one more way also to find slope. There is one more way also to find a slope. That is finding tan theta. Yes, sir, finding tan theta. Now I'm going to draw a small triangle over here. Yes, I'll take this one as theta. Now if you find tan theta, yes, tan theta. See, this theta and this theta both are same. Find tan theta. How to find tan theta? Tan. What is the definition of tan? Opposite side by adjacent side. Yes, opposite side by adjacent side. What is the opposite side? Yes, sir. This is the opposite side value. This for this small triangle. Let's take this one as let's take first of this time as some t1. Let's take this time as some t2. Then what is this value? R of t1. What is this value? R of t2. Tan theta means what? Opposite side. What is this length? R of t2 minus R of t1 by what is this? This is t2 minus t1. That is equal to a. So why these many methods we start to find slope at different applications or in a problem? Means sometimes only one formula among these formula will work. So that's why it's important to know what are all the methods to find slope. Tan theta and that y2 minus y1 by x2 minus x1 or derivative. Among all these three, which is a superior method? Derivative. Derivative way of finding slope is applicable for any given signal, what irrespective of its shape. If you want to find slope at a point, then substitute that point. So this is about ramp signal. Then what is unit ramp signal? R of t is equal to what? T into u of t. How much is a? A is equal to 1. A means what? A is nothing but slope. A is slope. Tan theta, slope. Tan theta is called a slope. I told you. Tan theta equal to 1. Then how much is theta? Theta equal to 45. Theta equal to 45 degrees. So this is about ramp and unit ramp. Now let's see how to get ramp signal from step signal. Integration of 0 to t. Step signal. Yes, step signal will give us ramp signal. Yes, let's see what is that. Let's take integration from minus infinity to t. No issues in the same way previously. Yes, sir. Now integral of minus infinity to t. What is step signal? A into u of t. If I call as unit step, then a is equal to 1. See, many students will not remember this point. If I call test step, they will substitute only u of t. If I call unit step, then it is u of t. If I call step, its height may be any value. Okay, please do particular at these points. A into u of t. dt. Now is equal to 0 if you are taking integration limit for t greater than 0. Means if you are doing this t value is for less than 0, suppose if this t value is less than 0, means you are doing the integration up to some value of some point of time where t is less than 0, then definitely this will be 0. Why? Because this u of t is 0. Is equal to a is a constant. What is it? This u of t is 1 for t greater than 0. U of t is 1 for t greater than 0. A into 1. 1 integration is what? For t greater than 0 means what? This minus infinity will not be there. That minus infinity will not be there. Yes or not? You are going to get what? T. Yes, sir. A into t for t greater than 0. For t greater than 0. Which signal is having this type of representation? Ramp signal. A into t for t greater than 0 equal to 0 for t less than 0. Which signal is having that representation? Ramp signal. Integration of step signal will give ramp. If you take unit step, if you integrate, what you are going to get? Unit ramp. Now from impulse also we can get ramp signal. One time you integrate, you get step signal. Second time you integrate, you are going to get a ramp signal. That much easy it is. What is our next discussion? Getting its Laplace transform. Getting its Laplace transform. From mathematics, I will give you one formula. Please do remember, in mathematics or in signals and systems, you are going to get the proof of it. We are not bothering about its proof. That is, remember this formula. Remember this formula. Laplace transform of this t power n into u of t. T power n into u of t. A into some constant a is equal to, a is constant, keep it outside. A is constant, keep it outside. N factorial by s power n plus 1. I think most of you done with mathematics in your graduation. Therefore, in mathematics you might see this identity. Okay, so a into n factorial by s power n plus 1. Now how I am going to use this one here? How I am going to use this one? Now I want Laplace transform of I want not example please, or standard identity I want Laplace transform of a t into u of t. I want Laplace transform of a into t into u of t. As a is constant, throw it outside. But how much power I have? 1. A t power 1. 1 factorial by s power 1 plus 1. How much I got? A by s square. Laplace transform of ramp signal is a by s square. Laplace transform of ramp signal is equal to a by s square. Now let me know what is the answer for this. What is the Laplace transform of unit ramp signal? Simply 1 by s square. Why? Because a equal to 1, that's it. In the answer what we got previously is that substitute a is equal to 1. Substitute a equal to 1. Come on here, ma. Now I'm asking a question here. Example question. Or first let me give the inverse Laplace also. Inverse Laplace also. Vice versa please. What is the inverse Laplace transform of a by s square? A is constant, throw it outside. Inverse Laplace transform of 1 by s square is t into u of t. T into u of t. Yeah, come on, brother. Here we discuss Laplace transform of t into u of t is 1 by s square. T into u of t is 1 by s square. Vice versa. Inverse Laplace transform of 1 by s square is equal to t into u of t. Just nothing. Simply apply inverse Laplace here, both sides. Here Laplace and inverse Laplace will cancel. Here inverse Laplace of 1 by s square, what you are left with? T into u of t. Very simple, brother. Okay, we got this one. Let's solve one simple problem. Without one pen paper, directly you can give the answer for this one. What is the inverse Laplace transform of 6 plus 8 into 8 by s plus 9 by s square? 9 by s square. Yes, the answer is, come on ma, 6 del of t plus 8 u of t plus 9 into t into u of t. 9 into t into u of t. That's how simple it is. Let me ask you one more question. What is the inverse Laplace transform of 6 plus 8 u of t? Yes, 6 plus 8 u of t. Some people will try to give the answer for that question. Nonsense it is. It's a nonsense. I am applying inverse Laplace for the thing which is already in time domain. Yes, this is not correct. What they will give you? No answer. 6 into del of t plus 8 by s. Nonsense it is. Yes, this is completely nonsense. So please do not be under an impression directly I can write. Observe it. This is already in time domain. For time domain, if you apply Laplace, you will get in S domain. Okay. You can't apply inverse Laplace for the thing which is in time domain. Okay, the question itself is wrong. So some people, out of their curiosity, they will give wrong answers here. That's why I taken that question. Okay, that's a nonsense question. That type of question does not exist, please. Now we are done with impulse, step, and ramp. The signal in this sequence we are left with is a parabolic signal. Parabolic signal. So impulse, step, ramp, and parabolic are called as standard signals or standard inputs. In laboratory, we are going to use this standard inputs. We will generate. In fact, if you want, we can generate these signals by using analog electronics, by using BJTs or MOSFETs or operational amplifiers. We can generate these signals in laboratory. Okay, these are standard signals. Let's go for the next signal, that is a parabolic signal. Yes, parabolic signal. Come on. We will represent this one as P of t. We will represent this one as P of t. Before I go for parabolic signal representation in the control systems, if you remember parabolas from intermediate, yes, we have parabolas like this. Y is equal to x square, x is equal to y square. Like this, we have parabolas. Y is equal to x square is a parabola. Y is equal to x square is a parabola. Let us draw the first one. Y is equal to x square parabola. Y is equal to x square parabola. So this is x-axis, this is a y-axis. Observe here carefully. Because to understand how I got the shape of the signal in control system, somewhat few points I want to understand here. Y is equal to x square. X is positive. Positive square will be positive. Yes, positive square will be positive. X is negative, but negative square is again positive. Yes, this is y is equal to x square parabola. The shape of y is equal to x square parabola. X is either positive or negative. Y is always positive. Why? Because positive or negative, its square is going to be positive. X is equal to y square parabola. X is equal to y square parabola. Let me draw the second one here. X is equal to y square parabola. Yes, this is x, this is y. Come on, dear. Come on. You can write. You can write. X is equal to y square. Y is positive. Y is positive. Y is positive. X value will be positive. Why? Because a positive square will be positive. Means this one. Y is negative. Y is negative here. Y is negative here. Yes, negative square will be positive. Yes, this is x is equal to y square parabola. So please do remember the shapes. Please do remember the shapes, or you can draw whenever you require. You can draw whenever you require. Okay. Come on here. Come on, all of you. This is x. That is x. Now here instead of x-axis, what I'm going to take here is here instead of x-axis we will take it as t. Here instead of y of t we will take it as p of t. Y of t will take it as a p of t. Yes. Now let's represent this one mathematically. What is the mathematical definition of parabola? We are going to see mathematical definition of parabola. Yes, p of t is equal to, here instead of x-axis what we are taking, time. Time is our independent variable in control systems, not only in control systems, rather mostly in the engineering. In engineering we are always dealing with the practical problems. Therefore, practically always the independent variable is what? Time. Okay, so equal to t square, yes, for t greater than 0. This is what extra in our control systems. Okay, here we draw y is equal to x square parabola for x value from minus infinity to plus infinity. But here in control system we need parabola only for t greater than 0. Only for t greater than 0. Means what part equal to 0? Let's complete it. Equal to 0 for t less than 0. Equal to 0 for t less than 0. Let me draw the graph of it. Let me draw the graph of it. T is equal to 0 is this one, boss. T is equal to 0 is this one. Now I want only right side. T square. I want only right side. Therefore, what to do? Total parabola is this one. Total parabola is this one. Let me show. Total parabola will be like this. Total parabola will be like this. But I need only right side part. What to do? I need only right side part. Just erase this one. This is parabolic signal. Without explaining you this one, if I draw this one, you may get one doubt. In intermediate or in diploma, we studied parabola as some U-shaped signal, but this fellow taken only what you called this part, how this is going to be served as parabola. Yes, this is a parabola. Only right side we are taking. Only right side we are taking. Now let's go for what you called the definition. We need to do further some modifications in the definition. What we got, parabola definition as p of t is equal to t square. This magnitude may be any value. not magnitude. That multiplication factor, it is not magnitude, please. In step function, a is magnitude. In ramp function, a is slope. What is a in parabolic function? We'll see. What is a in parabolic function? We are going to see. For t greater than 0, equal to 0, for t less than 0. For t less than 0. Let's find the what you called Laplace transform. Let's find the Laplace transform of parabolic signal. Let's find the Laplace transform of parabolic signal. Laplace transform of p of t. We just learned one mathematical identity. Yes, Laplace transform of what it is? A t square into u of t we can write. Yes, yes, this total can be written as a into t square into u of t. U of t will take care of t less than 0. 0 value, t greater than 0, it is existing. U of t will take care. Yes, what it is? I can throw a outside. I can throw a outside. Now, what is this? 2 factorial by s power 2 plus 1. Yeah, n factorial by s power n plus 1. Just now we saw that is equal to how much we got? A into 2 by s cube. A into 2 by s cube. Yes or not? Yes. How much it is? A into 2 by s cube. I do not want this 2 here. I do not want this 2 here. What to do? Divide with 2. Then what is the answer? A by s cube. As I don't want 2 here, therefore I have to divide here also. Yeah, here I divided. Here I have to divide. Therefore here I have to divide. Therefore here I have to divide. Yes. Therefore, come on here. Come on here. Here I have to divide with a. Anyhow, if a is equal to 1, it is called as unit parabolic signal. Yeah, in the same way, unit impulse, a equal to 1, where a is the area. Unit step, a equal to 1, where a is the step of the height of the step. A in ramp, a is what? Slope, a equal to 1. Unit ramp signal, theta is equal to 45 degrees. Here a equal to 1, it is called as unit parabolic signal. But parabolic means what? A t square by 2. Sir, is there any specific meaning for the 2? No, please. A t square is also parabola. T square is also parabola. 1.5 into t square is a parabola. But a t square by 2 is a standard parabolic signal. Yes. According to scientists, this a t square by 2 is a standard parabolic signal. To just make this standardization, we divide with 2. Let me write it once again to avoid your confusion. Let me write it once again. Yes. P of t is equal to, yes, a into t square by 2 into u of t, or the same we can write it as a into t square by 2 for t greater than 0 is equal to 0 for t less than 0. It is a standard parabolic signal. Okay, to make that standardization only we taken by 2. Yeah, this is a parabolic signal. Yes, p of t is equal to t square into u of t is a parabolic signal. 1.5 into t square is a parabolic signal, please. Okay, there is no offense. Yes, it's parabola. T square, if you have, it's parabola. But standard parabola means what? A t square by 2. A t square by 2. What is unit parabolic signal? If a equal to 1, if a equal to 1, then that signal is said to be, then not that signal, then p of t is said to be, then p of t is said to be, yes, is said to be unit parabolic signal. Yes, unit parabolic signal. E of t, that is said to be what? Unit parabolic signal. Unit parabolic signal. Yes or not? Yes, unit parabolic signal. What is unit parabolic signal? P of t is equal to what? Simply t square by 2 into u of t. T square by 2 into u of t. What is the Laplace transform of unit parabolic signal? That is what? Laplace transform of t square by 2. How much it is, ma? 1 by s cube. Simply we got a by s cube here. Yes, standardized parabolic signal. What is unit parabolic? A equal to 1. 1 by s cube. 1 by s cube. Now let's list these points. P of t is equal to a t square by 2 into u of t is parabola. P of t is equal to t square by 2 into u of t is unit parabolic signal. Its a Laplace transform is I can call simply P of s is equal to a by s cube. Here I call P of s as what? 1 by s cube. 1 by s cube. Laplace transform. That's it. Not more than that. I told you what is a here. What is a here? Before going what is a here, let's get a standard form if for any form. Let's get standard form for any form. So P of t is given not P of t. That fellow given like this. Examiner given f of t is equal to 1.5 t square into u of t. In this way given. It is not looking standard. What I want in terms of a into t square by 2. A into t square by 2. So what I'll do, I'll write this one as 3t square by 2. Then 3t square by 2 into u of t. Is there any change in value? 1.5, 3 by 2 into 3 by 2 is 1.5. Here, how much is the value of a? A equal to 3. A equal to 3. What is Laplace transform? A by s cube. What is the answer? P of f of s is equal to. I'm writing here. What is the answer? F of s. Come on here. F of s is equal to a is 3 into 1 by s cube. Yes, this is standard parabolic signal. A value is 3. A by s cube. Answer is 3 by s cube. To find Laplace and inverse Laplaces, making into standard form is important. Then you won't get any confused. So see, means 1.5 t square Laplace. In that way, in Laplace it is okay, fine. But when you're finding inverse Laplace, it is going to be very difficult for us. That's why, please, come on, always make into standard form. Make into standard form. Okay. Now, let us take inverse Laplace also. Inverse Laplace of 1 by s cube is what? Yes, t square by 2 into u of t. You must write that into u of t. Yes, otherwise it's not parabolic. Otherwise it's not a parabolic. Okay. Our control system parabolic, please. T square by 2 is a parabola, but in control system the parabolic signal is defined only for t greater than 0. Yes. Now what is the Laplace inverse Laplace of 3 by s cube? 3 keep outside. 1 by s cube means what? T square by 2 into u of t. An example, please. An example. Let's find inverse Laplace transform of 9 by s cube plus 7 by s square plus 6 by s plus 5 plus 5. Come on, very simple, ma. Directly within one step we are going to write 9 into t square by 2 into u of t. Yes, 9 keep outside 1 by s cube. Inverse Laplace is what? T square by 2. T square by 2. Why that 2? Just to cancel the 2 what we are getting in the numerator of Laplace transform we standardize it. T square by 2 is a standard parabola. Okay. And any t square into u of t is going to be a parabola, not an issue. 7 into what, ma? T into u of t plus 6 into u of t plus 5 into del of t plus 5 into del of t, please. Yes, this is the answer. So with this we are done with the basic standard signals. After this, few more signals we have, that is the exponential signal, sinusoidal signal, exponential signal and sinusoidal signal. And let's enter into exponential signal. When we are discussing exponential signal, I will be explaining you about a property. That is time shifting and frequency shifting. First we will discuss frequency shifting, then we go for time shifting. Come on here. Next signal is one of the very important signal throughout the control system, e power minus 2t, e power minus 3t, e power minus 4t. Like this exponential, always we get exponential signal. Okay, that's why it is very important. Come on, I'll ask you a question. Example, sketch exponential signal. Yes, sketch exponential signal. All of you try to sketch. If I ask you this question, try to sketch, please. Most of you will sketch like this. Okay. The first possibility what you are going to sketch is like this. First possibility what you are going to sketch is like this. Yes. This is t. This is t axis. Yes. First possibility. Second possibility what you are going to sketch is in this way. Come on here. Second possibility is in this way. Okay. Third possibility is, there are many possibilities of your thinking. Third possibility is in this way. Come on, observe here. Third possibility is in this way. So in many ways you are going to sketch, but the question itself is incomplete. The question itself is incomplete. Okay. Or if I ask you not sketch exponential signal, yes. If I ask you a question, let's keep it. If I ask you to sketch e power at, if I ask you then you'll sketch in this way. That is yeah. Let's take all the possibility axes. Then I'll show you all what you are going to sketch. First possibility, some students will sketch in this way. Some students will sketch in this way. Some students will sketch in this way. Okay. These are the possibilities. Question itself is incomplete, plus. Question itself is incomplete. Why the question is incomplete? Whether it is exponentially decreasing or is increasing depends upon the value of a. As I did not given the value of a, you must ask, sir, for what value of a? A is positive or negative? Yes. So depending on whether a is positive or negative, we are going to have different exponentials. Now let us, sketching exponential is very important. Number of times we are going to encounter exponential signal. Therefore, understanding in and out of the exponential signal is very important for us. Come on dear, very important discussion. E power at. First one is e power at for a greater than 0. I'm going to sketch. Not t greater than 0, brother. A is positive. Yes, come on. I'm taking axis here. Yes, this is t. This is 0. This is 0. Now for a greater than 0. This is t greater than 0, right? This is t greater than 0 axis. Yes, that is t greater than 0 axis. This is what axis? E power at. So this is what axis? T less than 0 axis. A is greater than 0. T is also greater than 0. E power. Come on here. E power at. Observe here. Very simple mathematical thing I am going to explain here. T is greater than 0 right side. Anyhow, A is also greater than 0 as we taken. Greater than 0 into greater than 0 is positive. As t increases, definitely this e power at is going to increase. As t increases, this e power at is going to increase. Means this side exponentially it is increasing. Right side it is exponentially increasing. One point you have to remember very carefully that at t is equal to 0, it is going to be 1. Some people will put without calculation t is equal to 0 as 0. E power 0 is going to be 1 boss. Okay. Now this is for t greater than 0. Now come on, e power at for t less than 0 means this side. Negative value is increasing. Negative side it is increasing means minus 2 is more negative when compared to minus 1. And suppose this positive, this is negative. Positive into negative will be negative. And that multiplication is keep on increasing as you are moving away from this 0 axis towards left side. Yes or not? Yes. Therefore, e power negative magnitude is increasing. Therefore, suppose you tell me e power minus 2 is more or e power minus 4 is more. E power minus 2 is more. E power minus 4 is less. Means I can say left side as you are moving towards left side, the values keep on decreasing. Means I can say one point that is right side exponential increasing, left side it is exponentially decreasing. If you are not good at this simple mathematics, take calculator, take simply e power 2t. Put t is equal to 0, 1, 2, 3, 4, 5. Right side done. Put t is equal to minus 1, minus 2, minus 3, minus 4, minus 5. Left side is done. Right side it is increasing, left side it is decreasing. If I draw the graph of it, it looks like this. Yes, this is. If you have some constant k here, that will be k here at t is equal to 0. If I take k into e power at, the value at t is equal to 0 will be k. Shape of the signal will remain same. Shape of the signal will remain same. Now observe very carefully. Yes, this is the right side exponentially increasing, left side it is decreasing. Now, second possibility. Let us sketch second possibility, please. Second possibility is, yes, what is that, man? E power at, yes, for a less than 0. A is less than 0. What is the example? Simply e power minus 2t. For example, I am taking, let us take the axis, please. Yes, let us take the axis. This is t. This is e power at axis. What we are taking here, e power at axis. This is t is equal to 0. And t is equal to 0. Anyhow, it is 1. For t greater than 0, minus 2 into positive will be positive. Yes, magnitude is increasing, but negative is there. Therefore, it is decreasing or increasing? Decreasing. If t increasing positive side, I can say positive side. Yes, e power minus 2t will be decreasing. What is e power 2 into infinity? E power minus 2 into infinity will be 0. Finally, as you are tending towards infinity, this side will become 0. This side, what happens? Left side, minus of the minus is a plus. Therefore, it is keep on increasing. Very simple mathematical analysis. If you are good at simple calculations, this is going to be very easy place. Mathematics. Now, yes, this is the signal. At t is equal to 0, it is going to be 1. So this is one of the possibility. In BTech, mostly you did not see this one or you did not see this one. What you saw in BTech is, I'm going to show that. What is the most common signal in BTech for you is e power at into u of t for a greater than 0. Suppose if I draw e power at into u of t for a greater than 0. Yes, come on here. This is e power 8 into u of t, right? This is e power 80, right? For a greater than 0. Come on, brother. Yes or not? Yes. This is e power 80 for a greater than 0. If I multiply here, let's find here itself. Let's find here itself. Third one I'm taking here. E power 80 into u of t for a greater than 0. E power 80 for a greater than 0 is this one. If I multiply with u of t, what I'm going to get? Only right side. Very simple, boss. Very simple. Only right side you are going to get. This is t equal to 0. This is t is equal to 0. I'm going to get like this. I'm going to get like this. You might not saw this one also in BTech. What you saw mostly in BTech is, now let's take here for t less than 0. This is fourth one, please. Third one we already drawn there. Third one we are already drawn. Come on. This is going to be the fourth one, please. And this is for a, come on, less than 0. Greater than 0 we are done with now. A less than 0. Now e power 80 for a less than 0 is already present here. E power 80 for a less than 0 is already present here. Now what we want? Into u of t means what? Only right side part we are going to get here. Yes. This is the signal mostly that you have seen in BTech. Yes. So if I ask you to draw exponential signal, mostly e power 80, most of the students will draw this one because they are familiar only with this one. But these many possibilities are there in what you call exponential signal. One point I forgot to discuss, that is about boundness of a signal. Boundness of a signal. Let us discuss that one also. Let me discuss about bounded signal. Just in one line I'll finish. What does it mean by bounded signal? I will give you few examples. Observe this one carefully, please. Exponential. So we have these many possibilities of exponentials. Okay, exponentially decreasing, increasing. That depends on the value of a and which side of time you are present. Now, what is a bounded signal? You will encounter about bounded signal in signals and systems, but we do not want that much depth. Just we want to know what is a bounded signal. Bounded signal is a signal whose value is measurable at any instant of time. Remember, brother, bounded signal is a signal whose magnitude is measurable at any instant of time. Now, come on here. I'll be taking. We have to find the Laplace of this exponential, please. Okay, just hold that one. Let me discuss about the bounded signal. Now, tell me, del of t bounded or unbounded? It is unbounded. Why? Because this signal magnitude at t is equal to 0, how much it is? Infinite. It is measurable or not measurable? Not measurable. Infinite magnitude is not measurable. So this del of t is what? Unbounded. Unbounded signal. Yes or not? Yes. Come on. U of t is bounded or unbounded? U of t is a bounded signal. Why? Because what its magnitude? Maybe 1 into u of t magnitude is 1, 2 into u of t magnitude is 2, 10 into u of t magnitude is 10. That's it. This is bounded. This is bounded signal. What is ramp signal? Unbounded. Why it is unbounded, sir? What is its formula or what is its function? A into t into u of t. At t is equal to infinity, how much is the magnitude? Infinite. Therefore, ramp is unbounded. P of t parabolic is also unbounded signal. Yes or not? Yes. Then what about exponentials? This exponential is bounded or unbounded? Bounded. This exponential is bounded. Yeah, its initial value is 1. After it is keep on decreasing. No issues. At any point of time, its value is measurable. Now, what is this exponential? Unbounded. This exponential unbounded. Yes. This exponential unbounded if I go towards minus infinity, bounded if I go towards what you call infinity. Means overall if you speak it is unbounded. From t is equal to 0 onwards if you speak it is bounded. So this is the meaning of bounded and unbounded. Yes or not? Yes. Now come on here. We want to find the Laplace transform of exponential. So Laplace transform of exponential. What is our exponential signal? E power at. What to do? Multiply with e power minus st and integrate it. Come on here. We are going to do it. Before I go for the Laplace transform of exponential, let me talk few points about shifting. What does it mean by shifting? I'll explain both the shiftings, time shifting and frequency shifting. Now, our variable is t Our variable is t. Okay, our variable is t. Now if I substitute t is equal to 0, how much I'm going to get? 0. So f of t is equal to t square is the function. F of t is equal to t square is the function. What is our variable ma? T. If this signal is shifted by 2 units, means what that must be shifted? T has to be shifted, not t square. Variable has to be shifted. I'll explain you in a more beautiful manner, by taking step function, which is very easy to us to discuss. Shifting. Just let me discuss about shifting. What are the shifting? First, let me discuss about time shifting. Then we go for frequency shifting. Then we go for exponential Laplace transform. Then we have some correlations to do. Okay. Now, u of t is the signal I'm taking. Yes. The first signal is u of t is the signal. I'm drawing it. Yes. Where the signal u of t starts. u of t is a signal which starts at t is equal to 0, whose magnitude is equal to 1. I want to shift this signal towards the right side. Right shifting. Simply drag the signal to the right side. That's it. Simply drag. Keep the axis as it is. Hold the signal and drag it towards the right side. How many units you want to shift to the right side? Suppose say 1 unit. Then you want to shift the signal to the right side by 1 unit. U of t minus 1, it is called as u of t minus 1. The variable t is shifted towards the right side. Sir, how to know it is the right side? T minus 1 is equal to 0, t is equal to 1. Where the signal should start at t is equal to 1. Means I'm drawing it. Observe, I'm drawing it. This is t is equal to 0. Simply, this is 1, this is t. Drag the signal towards the right side by 1 unit. That's enough. 1 unit. Now, let us sketch u of t minus 2. Now, what to do? Drag the signal towards right side by 2 units. Yes, this is 0, this is t. Now, this is t is equal to 2. This magnitude will remain same. This is 1. Yes or not? Yes. Now, observe here. This is called as a right shifting, right side shifting. Just you stand at origin and drag the signal towards right side by how many units? Those many units. And do remember one point in your mind always, that shifting means a variable only should be shifted, not a square of the variable, not a cube of the variable, not a root of the variable. Okay, a variable has to be shifted. Suppose if x is the signal, x minus 2, x square is the signal, x square minus 2 is not the right shifted by 2 units. X minus 2 whole square is right shifted by 2 units. This is correct, but not this. Here x square you are shifting by 2 units. Here x I am shifting by 2 units. Shifting means again and again I am stressing on the point, that is variable only has to be shifted, not its square or cube. Okay, this is called as right shifting. We are in time shifting. Yes, time axis, all axis we are taking time. We can understand time shifting very well, but frequency shifting there will be confusion. Why? Because our human understandable domain is time domain. Frequency domain, it is not completely understandable. That is easy for us to do calculations. Okay, so from frequency time shifting I will be explaining about frequency shifting. That's why you have to understand time shifting very well. Okay, I can't show these type of waveforms in frequency shifting. That's why understand very carefully here. Now, right shifting is also called as a delay. The signal got delayed. Many people will get confusion. Sir, this is at 0 here, this is at 2, this is more advanced. Advanced means not having more value when compared to the previous value. Or advanced means not going to the right side when compared to this one. No, please. You have to understand in this way. This is time, boss. This is time. Advance or delay, this is time. I'll tell you. You are starting your preparation in the morning 10 o'clock. Okay. You are starting your preparation in the morning 10 a.m. Yes, your friend already started at 9 a.m. I can say that he is advanced or not? He is advanced. Time is less value or more value? Less value. Means magnitude wise less value. Magnitude time is less means he is already started compared to you. So he is advanced or delayed? He is advanced. This is you, please. This is you. Your friend 1. One of your friend started at 11 o'clock. At 11 a.m. one of your friends started. Your friend F2. He is delayed compared to you by 1 hour. He is advanced compared to you by 1 hour. Especially electrical students are having a lot of confusion with respect to this shifting, time shifting, advance and delay. What they will feel is more is the value, more is advanced. No, not place. Okay, this signal is starting at t is equal to 0. This is starting at t is equal to 1. This is starting at t is equal to 1. When compared to these two signals, this is more delayed. This is less delayed when compared to this one. This is starting at t is equal to 0. This is 1. 1 second it is delayed. 2 seconds it is delayed. Right shifting version of a signal is also called as delayed signal. Yeah, I'll be writing here. Come on. Right shifting of a signal. Yes. Right shifting. Yes, is called as right shifting is delayed version of the signal. Delayed version. Right shifting will give, if you right shift a signal, it is going to give the delayed version of the given signal. Delayed version of the what ma? Given yes signal. Given signal. Yes. Let's understand about the left shifting also. Yes. Now the same u of t will take. Same u of t will take. U of t you know very well. Yes. Just roughly I'm sketching here. This is u of t. T is equal to 1. This is t. Yes. We want u of t plus 1. We want u of t plus 1. This is t. This is 0. Now make the t plus 1 is equal to 0. T is equal to minus 1. Means this signal is starting at t is equal to minus 1. If you want to know at what point of time the signal is starting, make that bracket term equal to 0. Here also we did the same. Make this bracket term equal to 0. T minus 2 equal to 0. T equal to 2. Yes, this is starting at t is equal to 2. Make this bracket term equal to 0. T minus 1 is equal to 0. T equal to 1. Yes, it is starting at t is equal to 1. Come on here. Here, observe here u of t plus 1. T plus 1 is equal to 0. T equal to minus 1. This signal is starting at t is equal to minus 1. Original signal is starting at 0. It is started already, means at minus 1 it is already started. Therefore this is the advanced version of the given signal. Now let us sketch u of t plus 3. U of t plus 3. Okay, let us sketch u of t plus 3. I am sketching over here. Observe u of t plus 3. This will start at where ma t equal to minus 3. This is more advanced when compared to this one. This is more advanced. So what is the note point here? What is the note point here? Yes, a very important point. Yes, left shifting. Left. Come on, ma. Shifting will give advanced version of the given signal of the given signal. So this is about shifting. And one point again I'm giving that is always variable has to be shifted, not the square or cube or root of the variable. That point you have to remember. You can write your own note point if you want that point. Yes, this is time shifting. What does it mean by frequency shifting? If suppose if f of s is there, what is its frequency shifting? F of s plus or minus a. F of s plus or minus a. I imagine that a is always a positive value, then plus a or minus a, or f of plus a, I will say f of plus a or minus a, no issues brother. F of plus a or minus a, come on, f of plus a or minus a, I'll take it as a minus a. A may be positive or negative. If a is positive, f of suppose a is equal to 2, f of s minus 2. If a is equal to minus 2, f of s plus 2, you are going to get this is the general signal. This is the shifted version. This is called as frequency shifting, time shifting and frequency shifting. Okay, we have to get the Laplace transform of exponential. After that, we'll come back again here about time shifting and frequency shifting. We are not done with completely time shifting. Okay, we are not yet done with. Come on here. Let's go for Laplace transform of exponential signal. Laplace transform of exponential signal. So Laplace transform of e power at. E power at. What is the answer, ma? Does not exist. I forgot to give a few what you call the identities. That is, if I ask you what is the Laplace transform of t, some of you may answer it as 1 by s square. Absolutely wrong. Why? Laplace transform of t into u of t is 1 by s square. If this u of t is not there, you have to take bilateral Laplace transform whose limits are existing from minus infinity to plus infinity. Yes or not? Yes. The limits are from where to where? Minus infinity to plus infinity. Lower limit is minus infinity. When you are done with the what you call the integration calculation, e power minus s into in place of t, you have to substitute minus infinity. E power minus of minus is e power plus infinity. What is e power infinity value? Infinite. Therefore, Laplace transform does not exist. If I ask you what is Laplace transform of t, I can simply say does not exist. If I ask you a question, what is a unilateral Laplace transform of t? Unilateral means by default u of t should be there, but because you are taking only from t is equal to 0 onwards. Yes or not? Integration limits you are taking from 0 onwards, or you are multiplying the signal with the u of t. Both are same. Unilateral means integration limits are from 0 to infinity. From 0 to infinity, upper limit is plus infinity, e power minus infinity will be 0. Lower limit is 0, e power 0 is 1. Therefore, it is going to be converged. If lower limit is existing as minus infinity, definitely that integration is going to be diverged. Laplace transform of t does not exist. Laplace transform of t into u of t is 1 by s square. Laplace transform of t is what does not exist. Does not exist. Okay, what is Laplace transform of t square? This also yes, does not exist. Does not exist. What is Laplace transform of t square into u of t? Yes, knowingly given. This is not in standard form. If it is as a t square by 2, then you are going to get 1 by s cube, t square by 2. Multiply with 2 and divide with 2. Yes, 2. I kept 2 here. I kept 2 here. What is Laplace transform 1 by s cube? Answer is what, ma? 2 by s cube. Therefore, having into u of t is very, very important. And one more thing, yes, please do remember these points. Does not exist. If no u of t, that's Laplace transform is not going to exist. Okay, so remember these points. Then come here, all of you. Now, what is Laplace transform of e power at? E power at is, first of all, the signal itself is unbounded signal, or forget about it. But if I ask if it is unbounded, see, the integration must be converged to get the Laplace transform. To get a Laplace transform of any signal, the integration must be converged. If integration is divergent, means you are getting infinite. Its Laplace transform does not exist. What is Laplace transform of e power at? I can simply say it does not exist. I want to find Laplace transform of e power at into u of t. E power at into u of t. Yes or not? E power at into u of t. How to do it, brother? How to do it? You know it very simple. Integration from 0 to infinity. Why, sir, from 0 to infinity? Why? Because I have u of t. As I have u of t, definitely yes, I can do it from 0 to infinity. E power at f of t into e power minus st dt. E power minus st dt. Yes, come on. Integral of 0 to infinity. Yes, take minus t common, e power minus t into s minus a dt. S minus a dt. If you do this one, you are going to get it as 1 by s minus a. 1 by s minus a. Remember this one. This will serve a lot of purpose in our control system discussion. Whether we are not yet entered into the definition of system and control system. All these things are very much required for me. Just by looking at the question, we must be in a position to give the answer if you know these things. Yes, that's why we are mastering all these techniques. Definitely, I need all these techniques to understand control systems. Okay, what is Laplace transform of e power at into u of t? 1 by s minus a. 1 by s minus a. Come on here. Come on. An example I'm taking. All of you answer. All of you try to answer. First question is, what is the Laplace transform of e power minus 2t into u of t? Yes, 1 by s minus of minus 1 by s plus 2. 1 by s plus 2. Come on, brother. Come on. 1 by s minus a. A is negative there. Minus of minus will be plus. And one more thing I want to write here. Inverse Laplace of 1 by s minus a is equal to e power at into u of t. E power at into u of t. Come on. Here, second question I will be taking here. What is the Laplace transform of e power 3t into u of t? E power 3t into u of t. Come on, dear. 1 by s minus 3. 1 by s minus 3. Yes or not? Yes. Now, let us understand in some different way. What is the understanding in different way? Come on here. Understanding in that way, what I'm going to take up now is going to be a very beautiful manner. Okay, what is that? Now, I will be taking one more example. What is the Laplace transform of e power minus 3t into u of t? E power minus 3t into u of t. What is Laplace transform of u of t? 1 by s. Laplace transform of u of t is what? 1 by s. Yes or not? Forget about this e power minus 3t. What is Laplace transform of u of t? 1 by s. Now I am giving a statement. See, if s is the variable, s minus 3 is nothing but a 3 units shifted version of this variable. Na? Come on, again, if t is the variable, t minus 3 is what? Right shifting of the variable by 3 units. T plus 3 is what? Left shift of the variable by 3 units. Left shift of the variable by 3 units. This is right shifting, left shifting. This is delayed, this is advanced. Yes or not? In the same way, this is time. In frequency domain, if s is the variable, come on, if s is the variable, s minus 3 is right shifting. Yes, I can't show the waveforms here. But variable is s. Instead of t, just I'm taking s. This is a right shifting. This is what? Left shifting. Yes or not? Time shifting and frequency shifting. If frequency corresponding variable is shifted, it is called as frequency shifting. If time corresponding variable t is got shifted, it is called as time shifting. Now, how to understand this one? I told you in a different way we are going to get this one. Now, u of t Laplace is 1 by s. What is the answer? We know the answer. What is the answer? 1 by s plus 3. Here what we have? Minus 3. Here what we have? Minus 3. But we are going to get here plus 3. Now how to understand this one, please? Yeah, this is our outcome. We did not directly wrote. We calculated this integration. We got 1 by s minus a. Now what my statement here? Observe the statement here. If a signal, this is my signal, please. This is my signal. If a signal in time domain, remember please, this is very important. This is the important way of understanding. If a signal in time domain is multiplied with exponential, it is multiplied with exponential, then its a corresponding answer in frequency domain will be shifted by a units with opposite sign. What does it mean? Let me write the answer now here very simply. Yes. E power minus 3t into u of t is the signal. Yes, u of t Laplace is 1 by s. As there is multiplication of exponential in time domain, the corresponding signal variable, frequency variable will be shifted by 3 units with opposite sign. What is the sign here? Minus. What should I get here? Plus. Plus. Yes or not? Yes. Now come on here. I will be giving one more example. Come on. I will be giving one more example. Yes. Laplace transform of yes, e power 60 into u of t. What is u of t Laplace? 1 by s. As I have 6 here, I am going to get minus 6. Now Laplace is okay. Let's come to inverse Laplace transform. The inverse Laplace transform will solve a very beautiful thing here for us. Very easily we are going to find inverse Laplace transform. Inverse Laplace transform of 1 by s plus 3. People will think a lot. Forget about plus 3 first. Okay. What is the signal I have? 1 by s. Instead of 1 by s, we are going to get u of t. Instead of 1 by s, what we are going to get? 1 by u of t. Instead of 1 by s, we are going to get u of t. As I have frequency shifting here instead of the in time domain, what should I get? Exponential. With what sign? Opposite sign. Here plus 3 is there. What should I get there? E power minus 3t. This much simply we have to write. See, I'll give the statement here. Please, vice versa you have to remember. If a signal in time domain is multiplied with exponential, then its corresponding variable in frequency domain will be shifted with the same units but with opposite sign. What is vice versa? If the frequency signal is having shifting in time domain, you are going to get exponential with opposite sign. Let us take a second example. That is inverse Laplace of 1 by s plus 3 whole square. Come on, brother. 1 by s plus 3 whole square. Here, I told you what has to be shifted. Signal, variable square or cube? Variable. Here, variable is shifted or not? Yes, variable is shifted. what my opinion is, what my way of solution is, forget about plus 3 first. Forget about plus 3. What we have 1 by s square na? I am telling you to forget about plus 3. What is the signal you have? If you close this plus 3, what you have? 1 by s square. 1 by s square means what? T into u of t, brother. As I have shifting here in frequency domain, what I should get? I should get exponential in time domain with the opposite sign. E power minus 3t. Done. E power minus 3t. Yes or not? Yes, very much yes. Then let's go for the next example. Next example, third example, that is inverse Laplace transform of yes 1 by s plus 2 whole cube. I'll write whole cube. I'll write yes. Now what is the way? I told you very clearly. Forget about that plus 2. What you have? 1 by s cube. 1 by s cube inverse Laplace transform. What ma? T square by 2 into u of t. But as I have plus 2 here, e power minus 2t we should get. E power minus 2t. This is the way how to understand Laplace and inverse Laplaces very easily. Yes, sir. So the point here is in time domain, multiplication with exponential will give shifting in frequency domain. Shifting in frequency domain. Let's solve one more simple problem. What is inverse Laplace of s by s plus 1? S by s plus 1. Very simple. I want an answer from you. In 30 seconds, you can get the answer in 30 seconds. Not 30 seconds also require. Very simply. What is this? Inverse Laplace of s plus 1 minus 1 by s plus 1. Come on. Let's go to the next page. Yes. Inverse Laplace transform of s plus 1 minus 1 by s plus 1. Just I added 1 and subtracted 1. Added 1 and subtracted 1. What we are going to get? Inverse Laplace transform of s plus 1 by s plus 1 minus inverse Laplace transform of 1 by s plus 1. What we are going to get? 1 inverse Laplace transform of 1 minus inverse Laplace transform of what? 1 by s plus 1. What is inverse Laplace transform of 1? Del of t minus what is this? 1 by s. Forget about that plus 1. 1 by s you have. Instead of 1 by s, write u of t. As you have shifting by 1, what you have to write? An exponential e power minus t into u of t. E power minus t into u of t. This is the way to understand inverse Laplace transform. Not more than 2 steps. One step is for simplification, another step is just for writing inverse Laplace. For any problem, we should not take more than 2 steps. If it is having a lot of calculations, then third step we are going to take up. Yes, we are in the very starting. There are a lot of questions to solve in Laplace and inverse Laplace transform. Mostly we want inverse Laplace transform. If you know Laplace transform, inverse Laplace transform is going to be very easy. This is about exponential signal. See, if you remember, voltage across capacitor in a series RC network, okay, voltage across capacitor in a series RC network will rise exponentially. If you remove that voltage source and if you short it, the voltage across capacitor will discharge exponentially. Exponential is having a lot of use in control systems, in network analysis, and in many subjects in analog electronics and all these things. So do understand about exponential carefully, okay? So this is about exponential. We are done with frequency shifting. Only one point you have to remember from frequency shifting is that in time domain with exponential, frequency domain will be shifted. Then we have to discuss about time shifting. After this, we will go with time shifting.